In this video, we introduce the idea of classes and objects in Java. Classes and objects are the foundation of Java's approach to object-oriented programming. A class is a concept of an object. When you create a class, you create a new data type. You can think of a class like a blueprint or a recipe. You define a class, and then you use that class to create multiple objects from it. So the class is like the blueprint, and the objects are like the houses built from that blueprint. Or the class is like the recipe, and the objects are the cakes baked based on that recipe. A class defines what an object looks like, the object's characteristics. It does this by specifying the instance data variables. A class also defines what an object can do or what actions can be done to the object, its behaviors. It does this by specifying methods. Each object you create using your class has its own set of characteristics and can take the actions defined in the class. Remember to follow naming conventions for classes. Classes should use upper camel case with no underscores. Often class names will be single nouns because a class describes a single object. This example class defines a new data type called dog. This is the class header. You might think of a class like this being used in a software system for a veterinarian's office or an animal shelter. The class will define what characteristics describe a dog and what actions a dog can take. You can use this class to create multiple dog objects. There are some basic building blocks that should be included in all of the classes you write. These are instance data variables, constructors, getters and setters, and a toString method. Once you include these basic building blocks, you can then add on any of the class-specific methods that represent the behaviors you want your objects to take. Your instance data variables represent the characteristics or attributes of your object. You'll also hear these called fields, data members, or instance variables. Each object will have its own set of these variables. Instance data variables are declared inside of the class, but outside of any method. Follow naming conventions for your instance data variables. They should be lower camel case without underscores, and they should have descriptive names. Be careful to choose the right data type for each characteristic. Text characteristics should be stored with char or string. For numeric variables, think about whether you need to have a decimal or not. Characteristics that have two states, like true, false, selected, unselected, or yes, no, should most likely be a Boolean type. It's important to always declare your instance data variables as private. A big idea in Java and other object-oriented languages is encapsulation. This is the idea of each class being in charge of and protecting its own data and functionality. The behind-the-scenes implementation details should be hidden from anyone using your class. Declaring your instance data variables as private means that no other class can directly access or change the values of those variables. Someone using your class can only interact with the object through the public methods provided, not by directly manipulating the object's characteristics. Writing your class in this way is important so that you support encapsulation. This could be the list of instance data variables for our example dog class. They describe the characteristics of a dog object. They're declared as private, there are some strings, an int, and a Boolean, and they all follow naming conventions. Notice that they're also declared inside the class, but outside of any method. The next important building block is the constructor, a special method whose job it is to set up your object. The constructor always has the same name as the class, and it has no return type. The constructor either takes in parameters and uses those values to initialize the instance data variables, or it initializes the variables with default values. Let's pretend we only have 3 instance data variables for our dog class to keep things a little simpler: the name, the ID, and the age. This might be what our constructor would look like. The constructor takes in parameters with these values for ID, name, and age, and uses those values to initialize the instance data variables. The constructor might also not take in a parameter and use a default value instead, like in this example where we have a default age. You create your object by using the keyword new and a call to the constructor. This is called instantiating the object or creating an instance of the class. When you use the new keyword to instantiate an object, enough space is allocated in memory for all the characteristics of your object, as defined by the instance data variables. Next, the code inside your constructor is executed. This code should initialize your instance data variables, as we just saw. And finally, a reference to that memory space is returned so that it can be stored in your newly declared and initialized variable. In our example, when we use the new keyword with the dog constructor, sending along 2 strings, enough space is allocated in memory for a dog object. The constructor is then executed using the parameters and the default value to initialize the instance data variables. The reference to that memory address is then returned and stored in the MyDog variable. Remember that you declared your instance data variables as private to support encapsulation, but it's likely you'll want to allow someone using your class to access the characteristics of the object and maybe even change them too. They can't do this directly because those variables are private, but you can allow this through public getter and setter methods. Getter methods allow someone to access the characteristics of an object. All the getter method does is just return the instance data variable. Setter methods allow someone to change the characteristics of an object. A setter method takes in a parameter with a new value and uses that value to update the instance data variable. One benefit of using a public setter method instead of just the variables being public is that you can put code inside of your setter method to make sure that only valid, reasonable values are used for the object's characteristics. This allows you to make sure that you maintain data integrity. In our example, we would want to make sure that age is not allowed to be set to a negative number. You can also choose to omit a setter if you want a characteristic to be able to be seen and accessed, but not changed. The final building block is the toString method, which returns a text representation of the object. This is the final basic building block, and this method should always be included in classes you write because it's used very often. When you include a toString method, it means that you can put your objects directly inside of a printline statement or concatenate them with other strings. Your toString method must have this exact method header, public string toString with no parameters. It has to be this exactly. We'll learn why at another time. These are the basic building blocks of your class. Once you define these, you have created your new data type. And you can now write the class-specific methods that define the specific functionality for your objects. And this is often the fun part. Think about what functionality your object should have. Should the methods change the state characteristics of your object, or should they send back any information? When you create your class-specific methods, carefully consider your method headers. What kind of input should the method take? Remember that the instance data variables are already inside the class, so you can access them from any method in the class. But if a method needs outside information to accomplish its task, it should take in a parameter. When specifying the return type, think about what kind of information, if any, the method will send out. Is the method asking a yes or no question? Consider a Boolean return type. Is the method calculating something? Consider maybe an int or double. A method might also accomplish a task without returning any data. Consider a void method for that kind of functionality. And of course, remember to follow naming conventions for methods too. Lower camel case with no underscores, and the name should be descriptive. Here might be some methods for our dog class. The walk method is void. It accomplishes the task of indicating this dog is going for a walk. The birthday method is also void, but it would change the state of the object by increasing the age by 1. The age in human years method would calculate and return the dog's age in human years. And a method to send information about this dog out to someone so they can adopt the dog would take in the email address as a parameter. These are of course just some ideas for methods that might go in this class. Below is also some example code that might go in a main method. In this code, we use the MyDog object we declared earlier as the invoking object, and we invoke the getter method for name and 2 of the class-specific methods that we just described. Writing your own classes is a big part of being a Java programmer. This is a foundational idea in Java, so you should make sure to spend lots of time practicing these ideas. And always stay classy, Java monsters.